The homeowner discovered it on a Tuesday morning in March 2023. Black mold spreading like dark fingers across the basement walls of his $340,000 home, built just 12 years earlier with every modern convenience and code requirement. The musty smell had been growing stronger for months, but now the visual evidence was undeniable. Dark patches bloomed behind the finished drywall, and when he pulled away a section near the corner, the contamination went deeper than he'd feared. The foundation engineer arrived 3 days later with moisture meters and infrared cameras. The diagnosis was swift and devastating. Water was wicking upward through the concrete slab itself, creating perfect conditions for mold growth at the interface where wood subflooring met concrete. The repair estimate came to $45,000, and even then, the engineer couldn't guarantee the problem wouldn't return. The moisture was coming from below, through microscopic pores in the concrete that connected directly to groundwater. No amount of surface sealing would stop it permanently. This wasn't an isolated case. Across temperate climates from Georgia to Minnesota, moisture problems plague modern slab-on-grade construction with predictable regularity. The solutions offered by remediation companies have become a booming industry. Industrial dehumidifiers running 24 hours a day, chemical treatments that need renewal every few years, vapor barriers that eventually fail at the seams. Homeowners spend thousands annually fighting moisture that seems to appear from nowhere in homes built to the highest modern standards. Yet 500 miles away, in the mountains of North Carolina, stands a cabin that makes no sense by contemporary building logic. Built in 1868 by settlers who could neither read nor write, it rests on a foundation of rough-stacked stones with no mortar binding them together. The gaps between stones are clearly visible, seemingly inviting moisture to enter from all directions. Any modern building inspector would condemn such a foundation as fundamentally unsound. But the floor joists in that mountain cabin are as dry and solid as the day they were hewn from chestnut logs. After 156 years of mountain weather, including decades of acid rain and temperature swings from 20 below zero to 95 degrees, the wood shows no signs of rot, no termite damage, no moisture problems whatsoever. The original stone foundation creates a 28-inch gap beneath the cabin floor, and every stone remains exactly where mountain hands placed it more than a century and a half ago. The contrast defies explanation. Contemporary builders with engineering degrees, advanced materials, and sophisticated moisture control systems cannot solve problems that illiterate mountain settlers prevented completely using nothing but hand-selected stones and patient labor. The modern home required 1 day to pour its concrete foundation, while the mountain cabin took nearly 4 weeks of manual stone stacking. Yet the expensive modern solution fails within 15 years, while the primitive mountain approach endures for generations without maintenance. How did people with no formal education, no moisture meters, no building codes, and no engineered materials solve moisture problems that plague modern construction? What did they understand about water, air, and wood that our advanced building science has somehow forgotten in its rush to build faster and cheaper? The answer lies not in ignorance or accident, but in a sophisticated understanding of natural systems that took generations to perfect through careful observation and patient testing. In the valleys and gentler lowlands of 19th century America, conventional wisdom dictated efficiency above all else. Builders from Pennsylvania to Georgia followed a practical approach that made perfect sense to the business-minded. Construct foundations using minimal stone piers, often just 6 to 12 inches high, or place buildings in direct contact with the ground. Why waste weeks stacking elaborate stone walls when a cabin could be erected quickly and settlers could turn their attention to the urgent work of clearing fields and planting crops? This lowland method worked well enough in drier climates and flatter terrain. Valley builders took pride in their pragmatic approach, completing entire cabins in the time it took their mountain neighbors to finish just the foundation. They viewed their efficiency as evidence of superior thinking, a triumph of common sense over backward superstition. The criticism was direct and frequent. 3 weeks stacking stone when you could be clearing fields and getting a crop in the ground. But arriving in the Appalachian highlands were settlers of different stock entirely. Scots-Irish families who had survived the harsh hills of Ulster, German immigrants from mountain valleys of the Rhine, English families who had worked the rocky uplands of Yorkshire. These people brought something more valuable than efficiency. They brought the hard-earned knowledge of what happened to buildings in challenging environments over the long term. When these mountain settlers insisted on spending nearly a month hand-selecting and carefully stacking massive stone foundations, their valley neighbors were openly dismissive. Even other mountain people from lower elevations initially resisted the practice, viewing it as unnecessary labor that delayed more urgent survival tasks. The extra work seemed particularly foolish when valley cabins appeared just as sturdy in their first few years of existence. The mountain builders faced constant mockery for their obsessive foundation work. Neighbors would point to valley cabins that looked identical to the raised mountain structures, asking why anyone would waste precious summer months on elaborate stonework when simpler methods produced the same immediate results. The criticism wasn't limited to technique, it extended to character. Lowland builders characterized the mountain approach as evidence of impractical thinking, the stubborn adherence to old country methods that had no place in the practical demands of American frontier life. What the critics couldn't see was what the mountain settlers were actually observing. These weren't people following blind tradition or showing off their masonry skills. They were watching carefully, season after season, noting which cabins developed problems after particularly wet years, which structures attracted destructive insects, which buildings required constant maintenance, and which endured without intervention. Their backwardness was actually sophisticated empirical observation, testing approaches across the harsh cycles of mountain weather that revealed the true long-term performance of different construction methods. The mountain builders weren't just stacking stones, they were conducting experiments that would take decades to complete. And within 20 years, their patient methodology would transform skeptics into desperate students, as the fundamental differences between quick construction and permanent construction became impossible to ignore. The technique that seemed so primitive to outsiders was actually engineering of remarkable sophistication. Mountain settlers stacked stones to create a continuous cavity 24 to 30 inches high beneath the entire cabin floor. This wasn't simply about height. The foundation walls included strategic gaps between stones every few feet, ensuring airflow could enter from all sides. The floor joists rested on carefully selected flat capstones placed atop the walls, creating a complete air envelope underneath the living space that remained separate from ground contact. What the mountain builders understood, without ever naming it scientifically, was that wood rot requires 3 specific conditions to occur simultaneously: moisture above 20%, warm temperatures, and stagnant air. Their raised foundation system systematically eliminated the third factor. Continuous air movement kept the underfloor environment at 40 to 55% humidity, regardless of rainfall or seasonal moisture. Wood simply cannot rot when maintained below 60% moisture content, and the constant airflow prevented moisture from accumulating even during the wettest mountain springs. Modern slab-on-grade construction creates the exact opposite conditions. Concrete poured directly on earth creates an unbreakable connection between ground moisture and the wood structure above. Concrete appears solid, but it's actually porous. Moisture wicks upward through microscopic capillary action, carrying ground humidity directly to the interface where floor joists meet the foundation. With no air movement possible beneath a solid slab, moisture accumulates precisely where wood contacts concrete, creating perfect conditions for rot that begins from the bottom up. The contrast in longevity reflects this fundamental difference in approach. Modern homes built on concrete slabs typically experience floor joist deterioration within 15 to 25 years, requiring expensive repairs or complete subfloor replacement. The mountain cabins, with their simple raised stone foundations, maintain floor joists at 12 to 14% moisture content, the optimal range for dimensional stability and rot prevention, century after century without intervention. Consider the numbers that mountain builders achieved through observation rather than calculation. Air changes underneath a properly constructed raised foundation occur 4 to 8 times per hour naturally, driven by temperature differences and wind pressure. Modern building codes require only 1 square foot of crawl space ventilation per 150 square feet of floor area, a ratio that proves inadequate in practice, leading to the moisture problems that plague contemporary construction. The mountain approach achieved ventilation ratios closer to 1 square foot of opening per 25 square feet of floor area through better design principles. The irony becomes clear when examining modern solutions to moisture problems that the raised stone foundation prevented entirely. Contemporary homes require powered ventilation systems, vapor barriers, moisture meters, and chemical treatments, all attempting to control moisture that mountain foundations never allowed to accumulate in the first place. A modern crawl space typically maintains humidity levels between 70 and 85%, well above the threshold where wood begins to deteriorate. The mountain foundation approach kept underfloor humidity consistently below 55%, using nothing but strategic stone placement and natural airflow. Testing of original floor joists from 1870s mountain cabins consistently shows moisture content between 12 and 14%, exactly the range that modern kiln-dried lumber is processed to achieve. These mountain builders, working with green timber and hand tools, created conditions that preserved wood better than climate-controlled lumber warehouses. Their patient stone stacking wasn't primitive construction, it was sophisticated systems thinking that worked with natural forces rather than fighting them. But the genius of mountain foundation construction extended far beyond simply lifting cabins off the ground. The stone selection process revealed knowledge that took generations to accumulate. Mountain builders didn't use just any available stones, they specifically sought flat-bedded stones from sandstone and limestone formations that naturally stacked in stable configurations. Round river stones, despite being plentiful and easy to gather, were deliberately avoided because they would shift and settle unpredictably under load. Each stone was hand-selected not just for size, but for how its surface would nest securely with its neighbors. The size hierarchy followed precise logic that conventional builders considered unnecessarily complicated. The bottom course used the largest stones available, typically weighing between 200 and 400 pounds each. These massive foundation stones were partially buried to create an absolutely stable base that could not shift even during spring freeze-thaw cycles. Each successive course used progressively smaller stones, creating a natural taper that distributed weight evenly while maintaining structural integrity. This pyramid principle, applied horizontally rather than vertically, created foundations that became more stable under load rather than less stable. Perhaps most revolutionary was the complete absence of mortar between stones. To contemporary builders, this seemed like construction madness. How could a wall hold together without binding agent to lock the stones in place? The mountain approach appeared to violate every principle of conventional masonry, which depended on mortar to create monolithic structures that acted as single rigid units. What the mountain builders understood was that flexibility, not rigidity, created permanent foundations. Mortar joints inevitably crack as buildings settle and ground moves through seasonal changes. Once cracked, mortar allows water to enter but prevents it from draining out, creating the exact moisture accumulation problems that destroy foundations over time. Dry stacked stones, by contrast, could flex and adjust to ground movement without failing. Each stone remained locked in place by weight and friction, creating a foundation that was simultaneously flexible and immovably stable. The drainage architecture built into dry stone foundations solved problems that modern engineering approaches with expensive complexity. Strategic gaps every 4 to 6 feet along the foundation walls ensured that any water entering the foundation, whether from rain splash, surface runoff, or groundwater, could drain straight through without accumulating. This eliminated hydrostatic pressure that destroys conventional foundations and prevented the frost-heaving damage that occurs when trapped water freezes and expands. Modern poured concrete foundations create the opposite effect entirely. Concrete is designed to be impermeable, which means it must be waterproofed from the outside to prevent water infiltration. When concrete inevitably cracks, and it always does as buildings settle and temperature changes create expansion and contraction, water enters the foundation but cannot exit. The rigid concrete structure traps moisture, creating perfect conditions for the very problems that mountain stone foundations prevented through built-in drainage. The time investment comparison reveals the fundamental difference in thinking between mountain builders and contemporary construction. A typical cabin foundation required 3 to 4 weeks of careful stone selection, transport, and stacking by two experienced men. But once completed, these foundations required zero maintenance for over a century. Modern concrete foundations can be poured and finished in a single day, but they require expensive drainage systems, waterproofing membranes, and eventual replacement. The question becomes, which approach actually saves time when measured across the lifespan of 3 generations? The raised stone foundation created something that mountain builders never intended but came to depend upon: a sophisticated microclimate control system that operated without human intervention. During brutal Appalachian winters, when outside temperatures plunged to 10 or 20 degrees below zero and the ground froze solid for months, the airspace beneath raised cabins maintained temperatures 15 to 25 degrees warmer than the outside air. This thermal buffer occurred because the underfloor space was shielded from wind, received slight radiant heat from the cabin above, and benefited from the insulating properties of still air itself. This winter warming effect prevented water pipes from freezing when plumbing was eventually added to mountain cabins, protected stored root vegetables, and preserved foods from freeze damage, and made cabin interiors 10 to 15 degrees easier to heat because the floor wasn't drawing heat directly into frozen ground. Mountain families discovered that cabins on raised foundations required significantly less firewood to maintain comfortable temperatures, a crucial advantage when heating fuel had to be cut, split, and hauled by hand. Summer brought an equally valuable but opposite effect. During oppressive Appalachian summers, when outside temperatures reached 85 to 95 degrees with stifling humidity, the shaded airflow beneath raised foundations created natural cooling. Air entering from the north side of the foundation would warm slightly as it moved through the underfloor space, then rise and exit from the south side, creating continuous circulation that kept the underfloor area 10 to 15 degrees cooler than outside air. This turned the cabin floor into a cooling element rather than a heat source, making interiors more comfortable during the hottest months. But perhaps the most remarkable benefit was one that mountain builders never planned for: complete termite prevention. Termites require 3 specific environmental conditions to establish destructive colonies: direct contact between wood and soil, moisture, warm, stable temperatures, and a protected environment free from temperature swings and air movement. The raised stone foundation systematically eliminated all 3 conditions that termites need to survive and reproduce. The 24 to 30-inch air gap prevented any soil contact. The temperature swings and constant airflow created a hostile environment for colony development, and the dry wood maintained at 12 to 14% moisture content was simply unpalatable to termites. The result was zero termite damage in mountain cabins built on properly constructed stone foundations, even after more than a century of exposure to termite-heavy mountain environments. This success stands in stark contrast to modern construction methods that inadvertently create ideal termite conditions. Ground contact construction provides easy access routes for subterranean termites, moisture-damaged wood becomes a preferred food source, and the stable temperatures of modern foundations create perfect colony environments. The contemporary termite treatment industry, worth over $2 billion annually, exists largely because modern building methods abandoned the natural termite, prevention that mountain stone foundations provided automatically. The mountain builders accomplished this multi-system solution without thermometers, humidity meters, or entomological knowledge. They simply observed over generations which cabins experienced problems and which didn't, gradually optimizing a foundation approach that addressed drainage, ventilation, thermal control, and pest prevention simultaneously. This represented engineering through patient observation across lifetimes rather than calculation, creating solutions that worked with natural systems instead of fighting them with chemical treatments and mechanical systems. By the 1880s and 1890s, the 20-year experiment was complete, and the results were undeniable. Valley cabins built on minimal stone piers or ground contact were showing the inevitable signs of failure. Floor joists in direct contact with earth moisture were rotting from the bottom up, requiring expensive replacement within 15 to 20 years. Termite damage was becoming widespread in lowland construction, creating ongoing repair costs that often exceeded the original building investment. Damp interiors plagued ground contact cabins, making them uncomfortable to occupy and difficult to heat efficiently. Meanwhile, the mountain cabins on raised stone foundations remained as sound and dry as the day they were completed. Original floor joists showed no signs of deterioration. Termite damage was completely absent, and interior conditions stayed comfortable year-round with minimal heating fuel. The contrast was so dramatic that former skeptics began making pilgrimages to mountain settlements, desperate to learn construction techniques they had previously mocked as wasteful and primitive. The transition period from 1890 to 1910 marked the vindication of mountain wisdom. Raised stone foundations became the preferred method even in valley construction, particularly among wealthy landowners who could afford to prioritize durability over construction speed. Building guides and architectural pattern books from the 1910s and 1920s specifically recommended raised stone foundations as the superior approach for permanent construction, acknowledging that the additional labor investment yielded buildings that lasted multiple generations without major repairs. This was the golden age of American foundation knowledge, when traditional mountain wisdom merged with broader acceptance to create some of the most durable residential construction in the nation's history. Wealthy farmers, successful merchants, and educated professionals specifically requested mountain-style foundations from builders, understanding that the higher initial cost would be recovered many times over through reduced maintenance and superior longevity. But this period of enlightened construction was destined to be brief. The post-World War II housing boom prioritized speed and volume over durability, driven by massive demand for veteran housing and suburban development. Concrete slab-on-grade construction offered irresistible advantages to developers. Foundations could be poured and ready for framing in a single day, eliminating the weeks of stone stacking that raised foundations required. Building codes were rewritten to favor methods that maximized construction speed, and raised foundations were increasingly classified as outdated or non-standard approaches. The irony of this transition becomes clear when examining the long-term costs. Homes built on concrete slabs during the 1950s through 1970s are now experiencing the foundation failures that mountain stone foundations prevented. Modern homeowners face moisture remediation costs averaging $25,000 to $60,000 over a 50-year home lifespan, expenses that simply didn't exist with properly constructed raised stone foundations. The moisture control industry, termite treatment services, and foundation repair businesses now generate billions in annual revenue solving problems that 18th century mountain builders eliminated through patient stone stacking. Today, in places like Cades Cove in the Great Smoky Mountains, visitors can still examine mountain cabins built during the 1850s through 1880s. These structures stand on their original stone foundations, with floor joists as sound as modern kiln-dried lumber. The chestnut logs remain intact, the stone foundations unchanged after 140 to 170 years of continuous exposure to mountain weather. Meanwhile, contemporary homes built during the past 50 years are already requiring second or third foundation systems, proving that the mountain builders' patient approach created genuinely permanent construction, while modern efficiency methods designed obsolescence into the foundation itself. What the raised stone foundation teaches extends far beyond construction technique. It reveals a fundamentally different relationship with time and permanence. The mountain builders invested weeks in work that wouldn't show its value for decades, while modern builders invest days in work that looks impressive immediately but fails invisibly over time. The difference represents building for your grandchildren versus building for this quarter's profit margin. Mountain settlers understood something that modern efficiency culture has forgotten. Time spent at the foundation determines everything that rises above it. This multi-generational perspective produced different decisions at every level of construction. Mountain builders knew they likely wouldn't live to see their cabin's 50th year, yet they built as if someone they loved would need the structure to be sound in 100 years. This time frame created a moral obligation that code minimum and industry standard construction cannot replicate. The question they asked wasn't, what's the cheapest way to meet requirements, but Will this still be sound when my grandchildren are old? The system's thinking embedded in mountain foundation construction reveals wisdom that modern specialization has fragmented. Every element of the raised stone foundation served multiple functions simultaneously: drainage and ventilation, and thermal buffer and pest prevention, all from the same carefully stacked stones. Contemporary construction approaches each problem with separate specialized systems: drainage, separate from insulation, separate from pest control, separate from thermal management. More specialized systems inevitably means more failure points, more maintenance requirements, and more opportunities for expensive repairs. The mountain approach achieved elegant simplicity that addressed root causes rather than symptoms. Modern construction treats moisture problems with dehumidifiers, vapor barriers, and chemical treatments, all attempting to control moisture that properly designed foundations never allow to accumulate. The raised stone foundation eliminated the problem at its source, creating conditions where moisture simply couldn't become a destructive force. For anyone building today, the principles remain as valid as they were in 1868. Raised foundations with continuous airflow still prevent moisture problems better than any vapor barrier system. Natural stone still provides superior drainage compared to waterproofing membranes that eventually fail. Thermal buffers created by air gaps still reduce heating and cooling loads more efficiently than adding insulation to structures built on thermal conducting concrete slabs. The knowledge isn't outdated. The patience and long-term thinking required for proper implementation was deliberately bred out of modern construction in favor of speed and immediate profit. But the deeper truth extends beyond construction into philosophy. This story isn't merely about foundations. It's about what societies lose when they stop observing natural systems and start trusting experts who profit from complexity. It's about the difference between wisdom tested across generations and innovation sold before long-term testing reveals its flaws. The mountain builders weren't more intelligent than modern engineers. They were more patient, more observant, and more honest about what actually works over time rather than what appears to work immediately. The final contrast returns us to where we began: the modern homeowner facing $45,000 in moisture repairs, and the mountain cabin standing solid after 156 years. One represents building for quarterly earnings reports and efficiency metrics. The other represents building as if your descendants will judge the quality of your work. The raised stone foundation isn't an obsolete relic of primitive construction. Our time frame for thinking about quality and permanence is what became obsolete.